Okay, so we are starting now. So my first question is, you just have to raise your hand and answer it, right? So my first question is,
Just connecting my
okay,
Bluetooth.
what? Srinivas, just turn on camera first. Turn on the camera. Why latch is table triggered? Why latch is legal triggered? Unmute and answer. Otherwise, pass the question. Srinivas, turn on camera. Otherwise, I will remove you. Okay, I am removing this person. Yeah, Geeta, you can answer. Why latch is legal triggered? You don't know answer, it is simple. You can pass the next question. Okay.
Right.
You want to answer?
Yes, sir. Sir, level trigger means the high level and low level triggered latches. That is for high level it is 1, and for the low level it is taking the clock as 0. But I don't know why it is level triggered, sir.
Okay, fine. So just Google it once after the interview, you will get.
Okay.
I will not
Okay.
tell you the answers here because it will be like I have to cover a lot of questions in 40 minutes, right? Difference
Okay.
between the asynchronous and synchronous reset. Difference between the asynchronous and synchronous reset with the application if possible.
Asynchronous and synchronous counters.
Reset, not counter.
Reset.
Yeah.
Sir, I know about asynchronous and synchronous counters, but not about race.
Okay, just Google it after the meeting. It is like RTL designing part related. Geeta, you want to answer?
Yes, sir. Sir, asynchronous reset means the all the resets connected to the flip-flops are the circuits, which is not sequential.
Okay.
But in synchronous reset, all are reset to the at the same time.
Okay. So tell me about the ASIC design flow. So do you know about ASIC design flow? Just tell me the steps. Jyoti, you want to tell? ASIC design flow.
1 minute, sir. I'm just I'm not I'm not getting your voice.
ASIC design flow steps. Okay, Geeta, you can answer. ASIC design flow steps.
Sir, but I didn't go through it because you told only for digital electronics.
At least answer the rough idea. No? You have the like RTL and whatever the steps are there. Not exactly, at least rough idea you can give in the interview, because if you are blank in the interview, it will be bad impact for you. Okay.
Yeah, sir, I know.
Okay. So no problem. Why is the need of the sequential circuit? What is the need of sequential circuits?
Sir, what is the need of?
Sequential circuit.
Yeah. So basically, can I answer?
Yeah, answer.
Yeah. Basically, we use combination circuits for if we give inputs, it process some logical operation and it gives the output based on the inputs and the selection inputs. But we don't have any memory in that combinational circuits. For the future purpose, and we use sequential circuits. In the sequential circuits, we have a memory element. This output depends on the present inputs and present state of the memory or past outputs. So that's why we use sequential circuits.
Okay, fine. Yeah, this is fine. Okay, next question is, what do you mean by setup time, hold time, clock screw, and clock jitter? 4 things I have asked. Setup time, hold time, clock screw, and clock jitter.
Setup time and hold time?
Yeah. Clock screw and clock jitter.
Clock skew and clock jitter.
Yeah.
Setup time is the time required for the input to be stable before the clock is applied. It is called the setup time. And hold time is the time required for the input to be stable after the clock is applied.
Clock skew and clock jitter.
Um, Clock skew and clock jitters, I didn't.
Okay. While
study them.
answering to what is setup time, hold time, just make the diagram also in the interview. Fine.
Yeah. Okay.
Just take care of it. So tell
Can I
me the
show it in that book, sir? Can I draw in book?
right now it is not needed as such because I have to
Okay.
cover a lot of questions. This is a quiz round, right?
Okay.
If I
Okay.
asking you 10 minutes question in one question, it is because I have to cover a lot of questions in this. This is a quiz, not an interview, right? So,
Okay. Okay.
so tell me the difference between the latch and flip flop fast. At least five differences you have to tell. Five differences between latch and flip flop. Geeta will answer.
Basically,
Yeah.
Geeta, yeah, tell me.
Yeah, so latches are the level triggered circuits, but in flip flops they are edge triggered, and again we have classifications in flip flops, synchronous flip flops and synchronous flip flops. In latches can be operated with the clock and without the clock is also possible. But in flip flops, the operated with the clock is needed for the flip flops, and for latches. Latches are quite faster than the flip flops, but in flip flops, they are because of the clock, it will much slower than the latches. And flip flops can be made up of latches, but latches by using the flip flops, it is not possible.
Why it is not possible?
So
Okay.
flip flops, yeah.
Just Google it once.
So
If you know, you can answer. Otherwise, Google it. You can answer if you know.
So I thought the flip flops are need because the need of clock. I think.
Just Google it also. So what
Yeah. Okay.
you know about time boring concept? Time boring concept. Time boring
Yeah.
concept.
So time borrowing means if the clock cycle with between the borrowing within the clock cycle means the fixed time limits. So it can borrow the time with the next cycle within that specific time for taken the execution. So it will the total time taken should be same, but it can borrow the time from the next clock cycle. That is time borrowing.
Also make the diagram in the interface. Also make
Yeah.
the.
Okay.
Okay. Next question is blocking and non-blocking assignment. Yeah.
Yeah, sir. Blocking and non-blocking. Blocking means the value assigned to the LHS and RHS. It should be maintained. Means the value evaluated in the RHS, which is allotted to the LHS part at the end of the simulation, means the time specified. But in the non-blocking, it will first it will not assign to that value directly at the current time. It will wait until that overall time period ends. So at last, it will allot the value to the LHS, the value evaluated. That is non-blocking.
Yeah. Jyoti, you want to say something? You want to answer this question? Assign blocking and non-blocking assignment.
Sir, I didn't
This
prepare
is
for
very low.
very.
Okay. Okay. This is very low question. Okay. Uh, tell me different type of delays. Different type of delays in digital
Different
circuit.
types
In digital circuit, what are the different type of delays?
delays. Network delays.
If you don't know, you can pass it. Pass it to the next person.
Yeah, no, sir, I
Yeah.
don't.
Geeta, you can answer.
So mainly time delay, which is the delays.
Propagation.
First one.
Uh, uh, so rise time, rise delay, hold delay, wire delay, gate delay, net delay, cold delay,
Yeah.
combinational part delay. Part delay is the main. Fine.
Yeah.
Then is clock Q delay and parasitic like RC circuit delays are there. You can Google it. You will get the answer in the proper manner. I will upload it in the YouTube also after like few days. So it will be not a question, right? It will be not a.
Yeah.
Okay. You know about intra and inter delay. Tell me the difference between inter and intra delay. Tina, just turn on the camera. Tina, please turn on the camera.
Sir, actually, I'm coming back from office. I'm in cab, so I just want to see it today. Like,
Okay,
how
you want to answer also? You can answer some questions or not?
Yes, I'll try. Like, yeah.
Okay, fine. Okay, fine. So what is the difference between inter and intra delay, Tina? Okay, Geeta, you can answer.
Yeah, so, for example, ash 5 is equal to some value. This is for intra delay, means it will that the at the time of 5 it will execute that value. But yeah, for example, a is equal to ash some value to that aside. This is inter. So at that after that 5 nanoseconds or something, that period time, it will allot to that value to the variable which is assigned. This is what about intra and inter.
Okay, tell me the difference between encoder and priority encoder. Jyoti, you can start. Jyoti, you can answer.
Encoder and priority encoder.
Yeah. And why we need a priority encoder? And what is the need of priority encoder?
Yeah, basically we use encoder for selecting 2 power n inputs. So selecting n inputs from the 2 power n inputs, that means it convert from n by 2 power n. But in the priority encoder, it gives preference for the particular input. When that input is given, then it will discard all the inputs and it will first perform that input and then it will go on to the next priority, which has the highest priority. It will process that input.
Okay. Geeta, you want to add something?
Yeah, sir. Sir, in your encoder, the output or some of the more than one outputs are high at the time. But why we because of that only we need we go for priority encoder, because we are based on the priority we can enable that what we need of that particular output which should be enabled. So that's why we need of priority encoder over encoder, sir. At the time only the one input one output will be high at the priority encoder.
Okay, fine. So do you know loading effect? Loading effect.
Loading effect.
Yeah. Okay, just Google it after the class. Loading effect in digital electronics, right? Okay. The next question is why latch is label triggered? Why latch is label triggered? Latch is label or age triggered? To tell me first.
Level triggered, sir.
Yeah, why
Latch
it
is
is?
a level triggered.
Yeah, why it is? Why it is not other like age triggered? If you don't know it, you can pass. Why will ask next?
Basically, we apply an enable input as a clock to the latches.
Okay.
It will respond to the input whenever there is a change in the input. At the high edge, that is positive level, positive level.
Okay.
Means if it is edge triggered, means that will be converted into flip flop, because that clock will be given to it.
Okay. Okay. Do you know about Fibonacci series? Fibonacci series in computer science, in programming, if you know. Fibonacci series.
Yes, sir.
So You can write a C programming for the Fibonacci series or not? Or not right now, but after the class we just Google it because it is recently asked in one interview. Fine. Okay. Do you know about metastability? Metastability. Metastability. Metastability.
Metastability.
Geeta, you want to answer?
So like,
Yeah, Tina, tell me.
so whenever our data changes at the clock, then this metastable state arises.
Okay. But this is
Whenever
not.
the output is not stable at one point, it will toggle from 1 to 0 and 0 to 1, and it will be called as metastability.
No, just Google it once. After the class, just Google it once. Okay. If I want to implement a full header using half header, how many half header I will need? What are the circuitry? Like how many half header are and how many gates, different gates are needed? Full header using half headers.
I think 2 half headers will be needed. Ladder means
This is a simple question. Yeah, Geeta, you can answer.
Yeah, so 2 full ladders.
2 half headers. Full header you have to
Yeah,
make.
2 off headers.
And
Yeah,
what
2
about
off
the
headers.
gate? One gate is also needed, I guess.
Yeah, so 1 gate is also needed because sum and carry will be the outputs.
Yeah. Okay. Fine. Okay. Just check it once also. Hmm. Do you know the equation of setup time and hold time? Hold time and setup time equation, you know?
No, sir.
Okay, just Google it after the class because this is very important. Whenever they ask the setup time and hold time, you have to make a diagram as well as the equation, right? Do you know the difference between positive and negative screw? Negative and positive screw.
negative and positive.
Screw, SKEW. Okay, no problem. Going to the next question. Have you implemented any circuits in FPGA? FPGA. Okay, tell me the difference between
No.
FPGA and ASIC. ASIC and FPGA difference you can tell.
FPGA is basically used for any for implementing for any microprocessor, but this ASIC is used for the specific application. It is not used for another circuits.
Okay. Okay, just Google it after the ones. At least at least 4 or 5 differences you have to tell in the interview. Right? So my next question: what is the need of the clock in the digital circuits? What is the need of the clock in digital circuits?
So to achieve synchronization.
Okay, okay, fine. But this is partially correct, or you have to explain with the diagram and all. This is partially correct, right? Okay.
Okay.
Okay. Difference between microprocessor and
clock,
microcontroller. Yeah, tell me. Jyoti, yeah, tell me.
if clock is not applied, then the output will not be stable. Like in latches, it will be it will toggle so many times. That's
You
why we
can,
go to
yeah,
the flip-flops.
in the interview, you can explain through the example. That will be best way, right? They will understand. Fine. Take an example, make a diagram, and explain it. Fine. My next question is: what is the difference between this microprocessor and microcontroller? It's simple question, yeah. You can tell. Jyoti, you can tell. Jyoti, Geeta, you can tell. Simple question it is.
Same thing like FPGA and ASIC. It is
Okay.
a microprocessor and microcontroller. The
No,
simple
no.
difference.
Just Google it. Just Google it. Just use different. Yeah. Geeta, you can answer. Yeah.
A microprocessor is the it follows the one human architecture, and microcontroller is follows by one human architecture, Harvard architecture.
No, just Google it once. Okay, okay. Tell me next.
And microprocessor is it is apply means application is used by in the computers or laptops like digital equipments, but microcontroller is assembled with the means the it is like a mini computer, like it has all the controller chips like whatever the external parts needed in the computer. So it is like a mini computer microcontroller, but it's microprocessor. It is just an processing unit.
Basic differences, one have the memory, one don't have the memory. Right?
Yeah,
That is
that's
first major difference. Otherwise,
yes,
you can give the examples, you can make a diagram and all. You can at least tell the four differences, but main difference is about the memory.
yes, sir.
Yes, sir. Also, this is used in embedded systems, like we can say.
You can give the answer like through a diagram and all, something like that, application and all. Okay. Do you know about program counter? Program counter in microprocessor. Okay, no problem if you don't know.
No.
So, clock getting and power getting, clock getting and power getting. It is power concept we have covered in power optimization classes. Clock getting and power getting.
Oh, sure. I need to work on it.
Okay, we can pass it if you don't know. Okay, Geeta, you can make a simple diagram of the architecture of FPGA. What are the component programmable unit? What are the LUTs? Do you know about the LUTs in FPGA?
Sir, LUTs.
LUTs. LUT.
No, sir. FPGA, I don't know. I need to work on
Yeah,
it.
we have a qubit lab interview in 5-6 days, right? How you will answer?
Yes, sir.
It is for
Yes,
the
sir.
FPGA profile only. How you will answer? You tell me.
Yes, sir. Yes, I know that.
Yeah. LUT, Tina, you know?
No, sir.
Okay. Just write down this question. You have to make a diagram of FPGA. In that, you will get to know about programmable units and what are the different components, right? Because that will be asked in this coming interview also, qubit lab. Okay. So my next question is application of buffer. You know about the buffer?
It is used to like it to want an delay. For that purpose, it is also used before without any changing the input.
For
Yeah.
isolation between circuits, also use buffers.
Okay. Okay. Do you know about the leakage power? Leakage power. And what are the different steps measure which we can prevent the leakage power? Like we can reduce the leakage power or reduce it completely. Leakage power. It is a concept of power optimization techniques we have covered already. At least you can tell there are different two type of powers are there. Statics and dynamics. You can write the formula. Something you
Yes,
have to tell in the interview. If you are completely blank, they will see that you don't have the interest, right? Something you have to tell in the interview. Whatever you know, you can tell them. But
yes, sir.
at least tell them, right? Okay.
Yeah, so static power distribution is when the circuit is in off condition, means it is not operating in not operating condition. That time also some power is lost, so it is consuming some power. That is called as static power dissipation. So in dynamic power dissipation, when it is in the operating condition, that time it will take more the power which is actually required. That is called as a dynamic power dissipation. So we can control it by supplying the accurate power supply, which is actually needed for the circuit, without giving the extra power. And we can control by controlling the threshold voltage, wherever the circuit is actually started to working.
Actually, we have explained in the class. It is in the NPTEL videos also. 5 or 6 methods are there. Right? You can tell the names of that methods and all. It is basically correlating the formula and all. You have to change the different values and all. Just check those videos, fine.
Yeah, okay.
Okay. Difference between SR, ROM and RAM. ROM and RAM. You want to answer? Anyone? RAM and ROM.
ROM is a read-only memory, means we can only read, perform read operations, while as RAM is the random access memory. When the power is off, the all data will be cleared from the RAM. We cannot, in ROM, we cannot perform any write operations, and the data will not be lost whenever the power is off.
Okay. What is difference between dynamic and static RAM? Dynamic and static RAM. Static and dynamic RAM.
Static and dynamic.
So you can pass if you don't know. You can answer, Geeta.
Yeah, so in dynamic RAM, we need an refresh time to retain the means, storage elements or something. But in static RAM, it didn't require the refresh times, refreshing moments, and also the whatever the when the power is lost, as unfortunately it get disconnected, the all the data will be lost in the static RAM. So it is not stores the performing operations. But in a dynamic RAM, it regain the data which is performed.
Make like at least 5 points because this is important question, right? Okay, fine. Do you know about body effect? It is part of analog electronics. Body effect.
Yeah, sir.
You want to answer? Body effect, you know?
Yeah, sir. I heard about it, but I
Yeah.
need to go through in deep.
Yeah.
I didn't.
Yeah, Jyoti, you want to answer?
No, sir, I didn't remember.
Okay, fine. Tina?
Actual definition, I didn't remember.
Okay, no problem. Do you know about false path? False path in STA. False path, multiple path. Okay, no problem. Next question is, what is difference between simulation and synthesis? What is difference between synthesis and simulation? Okay, if you don't know
What is
it,
difference between?
simulation and synthesis. Simulation and synthesis. It is simple question, yeah. Geeta, you know?
Yeah, so simulation, we usually run the whatever the code perform the logic. So it is not an actual performance with the support of hardware. But in
Just go.
synthesis, I think, yeah.
Yeah, tell me.
With the in synthesis, the actual hardware components, it is also the part of the process.
Just Google it after this thing. Okay, fine.
Yeah.
Okay. My next question is, how many? I want to implement 8 into 1 mux using 2 into 1 mux. How many mux I need? I want to implement 8 into 1 mux using 2 into 1 mux. How many mux I need? 2 into 1 mux. It's simple question.
Sir, I'm not. Sir, what?
I want to implement 8 into 1 mux using 2 into 1 mux. How many mux I need? You can make it a diagram or you can directly answer because this is a simple question. There is formula also for this.
Yeah, sir. 2 power n minus 1 means the formula is means the n is the number of bits, number of the bits.
But in the interview, you have
so,
to make it a diagram also, right?
yeah, okay. Sir.
Okay, what do you know about transmission gate? Tell me that what is the need of transmitter gate, transmission gate, and one application. What is the need of transmitter gate? Transmission gate. Tina, you want to answer? Transmitter gate. Okay, no problem. Do you know about noise margin? What do you mean by noise margin? Okay, no problem. If you don't know. You know, Geeta, noise margin?
No,
Okay.
sir.
Okay. How we can implement the AND gate using 2 into 1 mux? AND gate using 2 into 1 mux. It is simple question.
Yes, sir. 1 mux is needed. Enough.
1 mux. Okay.
Yeah, sir. The
what are the inputs?
Yeah, sir. If we take A as a select line, the zero select line will be connected to. So 1 second. Zeroth line is connected to. Zeroth line is connected to 0, and the 1th select line is connected to B. If we take
Make a
A as
diagram
a
also.
select.
Make a diagram also
Yeah,
in
okay.
the interview. My next question is this. Out of NAND gate and NOR gate, which is faster and why? NOR gate or NAND gate, which is faster and why? Or we can answer it like which gate we want to prefer in the circuits, like AND gate or NOR gate, and why?
So, sir, I think both are universal gates. So we can.
Both are universal,
can,
but which is faster? Which is faster? So just Google it. I guess NOR gate NOR gate is suitable sometimes. Just check the app. Which is faster. So we will prefer that, right?
Okay.
Just Google it once after the class. Okay. Do you know about CDC? CDC. This is the last question. This meeting will be ended in 1 minute. CDC.
No.
Okay, Tina. Okay, just
No,
check
sir,
this
not
question.
sure.
Okay. Tina, what you have prepared then? Okay, okay, fine. Just check it once. Prepare it well. Otherwise, you will be lagging because right now the session is going on. Fine. Just prepare it well. Don't be demotivated. Give as much as you want to give the mock intro, but don't get demotivated and give the mock intro daily. You can give, but don't get demotivated. This is for your practice only because if this situation is happening in the real interview, they will not give you the chance again and again. Here you will get the chance daily, but in the real
Yes,
interview,
sir.
you can improve right now, right? So improve it, right? So